Welcome and thank you for watching another video. Let's talk about covariance. The covariance indicates how two arrays move together. Here in our diagram we can check the returns on two different assets over time from 1990 to 2020. There are years where the covariance is positive and the returns on the two assets move together. There are other years where the covariance is negative and the good returns on the one asset are associated with the poor returns on the other. And of course, the covariance can be zero if the returns are not related. The covariance between the returns on two different assets is actually the product of two deviations. The deviation of the returns on asset A from its average return and the returns on asset B from its average return. This can be reflected by the following formulas that can be applied to estimate covariance. They are quite similar apart from the fact that the first is used when we have the entire population and the second one when we have a sample of the population. So the second one is much more commonly used. However, especially when you have a high number of observations, applying them to estimate covariance is extremely difficult and time-consuming. For this reason, in these cases, using a statistical package to estimate covariance cannot be avoided. Here is our example. We have the returns on the two different assets, asset A and asset B, from 1990 to 2020. And we want to calculate covariance, but we will not use any special statistical package. We will use Excel. Excel provides two different covariance functions. The first one considers that we have the entire population, whereas the second one considers that we have a sample of the population. So we will use the second one. We start typing the equal sign, covariance dot s. We open bracket and as a first argument we include the first array, and as a second argument we include the second array. We close bracket and here is our covariance that is positive. However, Excel provides a second way to calculate covariance, and this is through the covariance analysis tool. So from the menu bar we check data analysis, and we open up the data analysis package. From the scrolling list we select covariance. As an input range we select the returns on the two assets. We check the labels checkbox because we have selected the labels asset A and asset B as well. And the output range can be right here. And here is the output. However, as you can see, the covariance, even if it is positive, it is somehow different from the output of the covariance sample function. And the reason is because that the covariance analysis tool considers that we study the entire population. So if we use the covariance population function, the output is exactly the same with the output of the data analysis package of the covariance analysis tool. Here it is. However, as you can see, the output of the covariance analysis tool provides two additional values, and these are the covariance of asset A with asset A and the covariance of asset B with asset B. So these are not actually covariances, but they are the variances of asset A and asset B. However, be careful because when Excel calculates the variance of the two assets when it uses the covariance analysis tool, it assumes that we study the entire population. Thank you very much for watching.